Hello everyone, my name is Chauncey Celis and welcome to the presentation of my integrated project for ITM590 Capstone course. Today we are going to be talking about these objectives. First we're going to start off with the introduction, then we'll talk about what is the medical laboratory exactly, then some of the challenges faced in the medical laboratory. Next we will go over the effective information technology governance plans, and then how do we apply these principles to the medical laboratory. From there, we'll talk about the IT systems in healthcare / the medical laboratory, and then the IT systems in the United States Air Force. We'll also go over the technology deployment in the U.S. Air Force, and then we'll talk about some IT strategies in healthcare and the U.S. Air Force, and finally, we'll wrap it up talking over the IT improvement project. So, first off, what comes to mind when you think of IT in the United States Air Force? It's safe to assume that a lot of people think of battle-ready airmen on the forefront of a cyber war with our adversaries. They probably aren't thinking of the plethora of many other ways that IT is integrated and woven into the daily operations of many other work centers throughout the organization. And one such area of the Air Force that relies heavily on IT is the military healthcare system. And it is within this large organization that I am a part of, which is the clinical laboratory. So some of the information technology systems that are essential to medical laboratories in both clinical and research settings would be some things such as the laboratory information systems, otherwise known as LIS. You also have the electronic health records, or EHR, mobile health applications, and also some cloud computing. So what exactly is the medical laboratory, and what does a medical laboratory do? Simply put, a medical laboratory is a specialized facility where clinical tests are conducted on various bodily specimens such as blood, urine, tissue, and other body fluids. These tests are used to diagnose and monitor diseases, conditions, or the health of patients. Laboratories play a critical role in the healthcare system, employing a combination of sophisticated equipment and the expertise of medical technologists, technicians, and pathologists. They perform a wide array of tests, from simple measurements like blood glucose levels to more complex analyses such as genetic testing. So again, what are some of the IT systems within the laboratory? Like we had spoken of before, we have the electronic health record. So these are the records that keep patient information stored. And then within the laboratory, there's the laboratory information system, or LIS. These are just the systems within where results from these diagnostic tests are entered and stored for doctors to review. And again, there's also some laboratories do use certain things like cloud computing, where a lot of this data is uploaded into the cloud. So within that, again, as I mentioned, I am a part of the medical laboratory within the United States Air Force. So there are a few services that are kind of specific to the Department of Defense. Some of these are tailored to meet the unique needs of military personnel, their families, and veterans. So in addition to routine diagnostic testing, military medical laboratories are also involved in surveillance and research activities related to infectious diseases, environmental health, and biodefense to protect the health and readiness of military forces against potential biological threats. So again, within the medical laboratory sphere in the Department of Defense, there are a little bit more specific tasks that are performed in alignment with mission readiness. So, as with any industry, the medical laboratory does face some challenges. First, we'd like to talk about some of the social challenges that the laboratory faces. Really, the biggest social challenge right now being faced is like a workforce shortage due to a high demand for skilled professionals and also the retirement of experienced personnel, which leads to an increased workloads and stress among existing staff. Additionally, there is a growing need for enhanced public awareness and understanding of the critical role these laboratories play in healthcare, as misconceptions and underappreciation can impact funding, policy support, and the recruitment of new talent. A significant challenge right now regarding economics are the rising costs associated with advanced diagnostic technologies and the need for continuous investment in state-of-the-art equipment and training to keep pace with rapidly evolving medical science. Concurrently, laboratories are subjected to increasing financial pressures from the healthcare system and insurance providers demanding lower costs, leading to tighter budgets and reduced reimbursement rates for laboratory services. Moving on to some of the technological challenges faced within the medical laboratory. Medical laboratories currently face these challenges, and these include the rapid evolution of diagnostic technologies, requiring ongoing training and investment to stay at the forefront of medical diagnostics. Integrating new technologies into existing laboratory workflows can be complex and costly, necessitating significant resources for equipment acquisition, maintenance, and staff training. So beyond that, what are some of the issues faced with IT governance? One of the larger IT governance issues right now being faced by medical laboratories are in line with those faced by healthcare as a whole, ensuring data and network security and privacy for their systems, protecting patient information from breaches, unauthorized access, and cyber threats while complying with regulations like HIPAA, or the Health Insurance Portability and Accountability Act, in the U.S. is a paramount concern. Ensuring data security while enabling necessary access to healthcare providers is a delicate balance. And with all that, what does the future of the profession look like right now? A critical opportunity that medical laboratories, both civilian and military, will want to leverage in the future is artificial intelligence. We hear the practicality of integrating AI into different industries almost daily, and healthcare is no different. Artificial intelligence can be integrated into medical laboratories in several transformative ways to enhance efficiency and diagnostic capabilities. AI algorithms can automate routine tasks such as data entry and analysis, thus reducing manual errors and freeing up laboratory personnel for more complex tasks. In addition to that, machine learning models can interpret complex laboratory results such as imaging studies or genetic tests, providing rapid, accurate diagnostic support that can augment the decision-making process of pathologists and technicians. All right, so now we're going to move into effective information technology governance plans. So to ensure success through their IT governance plans, organizations must first ensure that they develop a sound and effective governance plan to begin with. But what exactly constitutes as an effective IT governance plan? First and foremost is laying the groundwork, and with that means choosing the right framework. Developing an effective IT governance plan is critical for organizations to align their IT strategies with business goals, ensuring that IT investments contribute to overall performance and compliance. And again, with that, the first step in this process is selecting an appropriate IT governance framework that resonates with the organization's size, culture, and industry. Frameworks like COBIT, or the Control Objectives for Information and Related Technology, ITIL, or the Information Technology Infrastructure Library, and ISO/IEC 27001 offer structured approaches for managing IT processes, resources, and risks. Choosing the right framework involves assessing the organization's specific needs, regulatory requirements, and strategic objectives. Once the framework is selected, it should be tailored to fit the organization's unique context, emphasizing areas of highest importance and potential impact on business outcomes. So what are the principles to ensuring success? Ensuring a smooth implementation of the IT governance plan requires careful planning, communication, and engagement at all levels of the organization. The overall success of an organization can be tied very closely to the overall efficacy of its IT structure, and this structure is a result of the IT governance plan. One of the key principles that an organization can leverage is the establishment of a governance committee. Establishing a governance committee or board that represents a cross-section of the organization, including IT and business leaders, to provide oversight and direction. This committee should work to clearly define roles, responsibilities, and accountability structure within the IT governance framework. As with all effective organizations, effective communication is crucial to ensuring success. Stakeholders should be kept informed and involved throughout the process to foster buy-in and ensure alignment with business goals. Training and awareness programs can equip staff with the necessary skills and understanding to navigate the new governance processes. Additionally, setting up regular review and audit mechanisms helps in monitoring performance against governance objectives, allowing for continuous improvement and adaptation to changing business needs and technological landscapes. So wrapping this all up, how is this used to foster organizational improvement? Organizations must keep pace with changes and make updates to remain successful in the new era. A key principle of this would be that IT governance ownership must shift from CIOs to the broader organizational leadership. IT governance is an enterprise capability and should therefore be championed by those in senior leadership. It shouldn't solely rest with the CIO, but rather it should be up to the board to determine the guardrails around issues such as risk tolerance, security, and compliance. Another key aspect to keep in mind is that governance should be updated more frequently than in the past. There is no formula for when to refresh a governance program. Rather, it should happen whenever organizational principles change or evolve. So now that we talked about that, how do we apply these principles to the medical laboratory? As we have seen, these principles can be leveraged to ensure the success of organizations, but can the same be said for organizations within the healthcare settings, such as the medical laboratory? To foster organizational improvement within a medical laboratory, management should focus on fostering a culture of continuous improvement, innovation, and quality. Much like in other industries and organizations, this involves investing in the ongoing education and training of staff to ensure they are skilled in the latest laboratory techniques and technologies. Encouraging open communication and feedback can help identify areas for improvement and innovative solutions. Implementing quality management systems, such as ISO 15189, can standardize processes and increase efficiency. How does this tie in to the overall success in healthcare information technology? Organizations within healthcare must leverage unique principles through healthcare information technology to remain successful. These principles may differ slightly from other industries because of the unique nature of medicine and patient care. An organization in healthcare can achieve success through the strategic use of health information technology by integrating advanced systems such as electronic health records, telehealth services, and data analytics to improve patient care, enhance operational efficiency, and support decision-making processes. By leveraging EHRs, healthcare providers can access and share patient information more effectively, ensuring that care is coordinated and patient-centered. Telehealth services expand access to care, especially in underserved areas, allowing for timely treatment and monitoring. Lastly, data analytics and artificial intelligence can analyze vast amounts of health data to identify trends, predict outcomes, and personalize care, leading to improved health outcomes and reduced costs. When it comes to developing an effective IT governance plan within healthcare, these are the principles that must be considered. So to expand on that, let's talk about the IT systems in healthcare and in the medical laboratory. In a healthcare setting, the information technology operating technology infrastructure is carefully designed to support the critical needs of medical environments, prioritizing patient safety, data security, and efficient care delivery. At its core, the infrastructure typically includes a robust network of servers and data storage solutions that manage vast amounts of patient data and support electronic health records. Workstations and mobile devices enable healthcare providers to access and update patient information in real time. Additionally, specialized software systems are employed for various functions such as diagnostics, patient management, and billing. The network is secured with advanced cybersecurity measures to protect sensitive health information against breaches and compliance with health regulations like the Health Insurance Portability and Accountability Act, or HIPAA. Lastly, backup systems and disaster recovery plans are essential components to ensure continuity of care in the event of system failures or other emergencies. Now, more specifically within the laboratory, there are information technology systems put in place there. In a clinical laboratory, the IT operating technology infrastructure is meticulously structured to handle complex data management and ensure seamless operation of diagnostic equipment. Central to this setup is a laboratory information system, or LIS, which integrates with various analytical instruments for automated data capture and tracking of samples throughout the testing process. Networking infrastructure connects these servers to both on-site and remote terminals, enabling technicians and pathologists to review results and collaborate efficiently. Additionally, stringent cybersecurity measures are implemented to safeguard sensitive medical data, complying with regulatory standards such as the aforementioned HIPAA. Typically, the IT systems within the laboratory are implemented and maintained by the hospital IT team. So in addition to the IT systems that I interact with in the medical laboratory, there are also IT systems within the United States Air Force as a whole. Information technology within the U.S. Air Force, and really the Department of Defense as a whole, is a vast, sophisticated, and secure network designed to support military operations both within the U.S. and across the globe. But how are these intricate systems implemented and set up? Because a lot of the cyber operations within the U.S. Air Force are top secret and or classified, we have to explore these systems from a more generic perspective. According to the Department of Defense, this infrastructure comprises an extensive array of secure and resilient communication systems, data centers, and mobile technology platforms that facilitate real-time data exchange and decision-making. Some key components of these systems include secure satellite and radio communications networks, advanced cybersecurity measures to protect sensitive information, and integrated command and control systems that enable coordinated operations across airspace and cyberspace domains. In addition, the U.S. Air Force also utilizes cloud computing solutions to enhance scalability and flexibility, ensuring that data and applications are accessible at all times to authorized personnel. Now, moving into the technology deployment within the U.S. Air Force, the organization follows the same steps that many other industries do. There are 6 steps that an organization usually follows regarding technology deployment: research and development, testing and evaluation, certification and approval, pilot implementation, full-scale deployment, and continuous improvement and upgrades. Research and development are the initial phase and involves the exploration and innovation of new technologies. Testing and evaluation assess functionality, reliability, and integration with existing systems. Certification and approval ensure that technology meets all regulatory, safety, and security standards. Pilot implementation is the rollout within a specific unit before mass release. This allows for real-world testing. The next step is the actual full-scale deployment, which involves large-scale production, distribution, and integration of the technology. And then lastly, continuous improvement and upgrades is the post-deployment phase, where the technology is monitored for performance and reliability. This can be applied to the implementation of any new technology, IT systems included. So now that we have the foundation of the IT systems in healthcare and the U.S. Air Force, what are some of the IT strategies that both of these organizations implement? One of the strategies that has been at the forefront of healthcare in the last few years has been that of digital transformation. Digital transformation in healthcare refers to the integration of digital technologies into all aspects of healthcare delivery, fundamentally changing how healthcare organizations operate and deliver services. As we have explored before, this transformation encompasses many different things such as electronic health records, telemedicine, AI, and big data analytics. Overall, the goal of digital transformation within healthcare is to improve patient outcomes, enhance the efficacy of healthcare services, and increase access to care. Overall, healthcare has the lowest level of digital innovation compared to other industries, such as media, finance, insurance, and retail, contributing to limited labor productivity growth. It is because of these low levels that many organizations within healthcare are shifting their strategies to focus more on this digital transformation. So what are some of the IT strategies within the U.S. Air Force? Typically, the Air Force aligns its IT strategies with that of the Department of Defense as a whole. The most current iteration of this strategical roadmap outlines 4 goals. The 4 goals of the cyber workforce strategy are: 1. Execute consistent capability assessment and analysis processes to stay ahead of force needs. 2. Establish an enterprise-wide talent management program to better align force capabilities with current and future requirements. 3. Facilitate a cultural shift to optimize department-wide personnel management activities. And 4. Foster collaboration and partnerships to enhance capability development, operational effectiveness, and career broadening experiences. Overall, the cyber workforce strategy focuses on the need to further the advancement of the cyber workforce in order to maintain an advantage in a contested and rapidly evolving cyberspace. The cyber workforce strategy outlines a series of goals and objectives that will enable the Department of Defense to identify, recruit, develop, and retain a more agile and effective cyber workforce. Now, with all of the strategies in place, what are some of the technological barriers that are faced? So within healthcare, there are several technological barriers to continued IT success, and many of them revolve around the healthcare IT systems themselves. One of the major challenges right now within healthcare is interoperability. This remains an issue as many different healthcare IT systems often struggle to communicate and share data effectively, leading to inefficiencies and potential errors in patient care. In addition, the high cost of implementing and maintaining advanced information technology solutions can be prohibitive for smaller or more under-resourced healthcare facilities. As always, cybersecurity is another significant concern, with the healthcare sector frequently targeted by cyber attacks due to the sensitive nature of patient data, requiring ongoing investments in security measures that can strain resources. Now, some of the technological barriers to continued IT success within the U.S. Air Force, perhaps actually one of the biggest barriers, are the ever-evolving threats within cybersecurity, legacy systems integration, and rapid technological advancements. Cybersecurity remains a critical concern because increasing digitalization exposes more aspects of operations to potential cyber attacks. A huge hurdle so far has been the integration of new technologies with existing legacy systems. Older platforms may not seamlessly support newer, more advanced technologies. This has been such a problem that many systems within the Air Force have completely stopped functioning because they could not be integrated. Lastly, the rapid pace of technological change, especially within IT, requires that the Air Force constantly adapt and update its infrastructure, something the organization has struggled with for decades. And lastly, to tie in all these aspects together, we are going to now focus on an IT improvement project. So the technological barriers that were mentioned before are the perfect segue into this improvement project that I would want to implement within my organization. So the two issues that I am trying to improve or fix upon will be to update the current operating system and perform minor hardware updates. Updating the operating system is crucial not only for accessing the latest features and improvements, but also for ensuring that the organization's systems are protected against vulnerabilities, thereby enhancing overall security and operational efficiency. Because right now, as it stands, my organization has yet to upgrade all the existing computers' operating systems. In addition to this, my improvement project would also be to complete small hardware updates, specifically the upgrading of RAM on all computers. I would want to upgrade the RAM on all the computers to enhance overall system performance and productivity. Increasing RAM allows more programs to run simultaneously and more data to be processed quickly, reducing lag and improving the speed of tasks such as loading software, browsing, and data processing. Additionally, upgrading RAM can extend the lifespan of these existing computers, delaying the need for full system replacements and offering a cost-effective way to boost performance. Now, in order to implement this IT improvement project, we had to develop a workable plan. Because upgrading operating systems and RAM requires careful consideration of various factors, including budget, compatibility, potential downtime, and personnel training, this workable plan will include 7 parts: assessment and planning, choosing vendors and products, testing, implementation, training and support, monitoring and evaluation, and ongoing maintenance. So the first phase would be the assessment and planning. Part of this phase will be to inventory our current systems, analyze our requirements, perform a budget estimation, and perform a risk assessment. Document the current operating systems and RAM specifications of all computers. Include hardware aids and any compatibility issues with new software. Next, determine the operating system versions and RAM requirements needed for the organization's software and operational needs. Next, estimate the cost for purchasing new operating systems, additional RAM, and any required hardware upgrades. And lastly, identify potential risks such as downtime, data loss, and compatibility issues. From there, we would have to choose vendors and products. First, choose operating systems that offer long-term support, security features, and compatibility with the applications we use. Next, we select RAM that is compatible with existing hardware and meets the new operating system requirements. Lastly, get quotes from multiple vendors for the software and hardware. Consider factors like price, support, warranty, and vendor reputation. Once that is complete, we will move into testing. First, we select a small group of computers to upgrade both operating system and RAM. With those, we would test for compatibility with existing applications and check performance improvements. Next, gather feedback from users about the new system performance and usability. And then lastly, make any necessary adjustments based on the pilot test results. After testing, we move into implementation. The first step to take will be to create a rollout schedule to minimize disruption. This may include doing upgrades during off hours or weekends. Next, we ensure all data is backed up before starting the upgrade process. Then we actually perform the upgrades, starting with the operating system installations followed by RAM upgrades. Lastly, we will update the IT asset management documentation to reflect the changes. From there, we go into training and support. After implementation, it is important to organize training sessions for users on the new operating systems. We will include tips on how to use new features and troubleshoot common issues. Next, we want to strengthen our IT support to handle increased inquiries and issues during and after the rollout. After this phase, we move into monitoring and evaluation. Here, we will monitor system performance, noting any significant improvements or ongoing issues with the new setup. Additionally, establish a feedback loop with users to continuously improve the IT infrastructure based on real user experiences. Lastly, after completion, we will analyze the overall cost versus the benefits in terms of performance improvement and reduced issues. Lastly, we will go into ongoing maintenance. The last step to enacting this project is the ongoing maintenance piece. First, we will be sure to schedule regular updates for the operating systems to ensure security and functionality. Also, we will plan for future hardware upgrades as part of the ongoing maintenance cycle. Overall, by following this structured plan, the organization can ensure that the IT infrastructure update is successful, minimize work disruption, and provide a solid foundation for future technology needs. So in summary, we went over several different things in our objective list. One of the bigger key items was that we highlighted the IT systems and infrastructure of both the medical laboratory and the United States Air Force. We briefly touched upon effective IT governance plans and all that goes into that, such as choosing the right framework. And then lastly, we went over an improvement project that I have planned to implement within my organization, which includes updating operating systems and upgrading the RAM on all the computers. Just want to thank everybody for being here today and listening to my presentation. Thank you very much.